So now we'll be dealing about the self-induction and mutual induction. Basically there are two types of induction. There are self-induction and mutual induction. Now before going on to this topic, I'll tell you about the Lenz law. Okay, Lenz law is basically a law which is used to find the direction of flow of current due to induced EMF. Now basically this law, Lenz law, it states that the direction of the induced EMF, it means the direction of the induced EMF in a current, in a circuit or a coil, it is such that it opposes the cause of that produces it. It means that, see, if this is the cause that is producing it, north, south, this is a magnet, okay, suppose this is a magnet, this is a coil. First I'll explain. See, this is a magnet, this is a coil, okay. Now when this magnet is moved towards this coil, obviously the flux linked here, it will change, okay, because this coil will be interfering with the magnetic flux, isn't it? See, its magnetic field is there. When it is moved here, then coil will interfere with it, okay. When it is interfered, induced EMF will be induced. Now that EMF will be induced in such a direction that it will oppose this source of induction. It will be produced in this direction such that this induced EMF will be produced in such a direction that it will repel this thing, okay. So this is Lenz law. It states that the induced EMF, it is of opposing nature. मतलब जिस direction से ये induce हो रहा है उसके opposite में ये induce होता है. The source, it opposes the source that produces it, okay. Now basically a question can be asked, what is Lenz law, and so that it is in accordance with the principle of conservation of energy. In 4 marks this question can be asked, okay. Now there is a short paragraph of explanation how it is in accordance with the conservation of energy. You can see your book if you want that paragraph. It's very easy, okay. I'm telling you how it is in accordance. See, first of all, this magnet is brought towards this coil using mechanical energy, isn't it? We are providing mechanical energy to move this magnet towards this mechanical energy. As this magnet moves towards this, magnetic flux changes and electric current or induced EMF is produced. It means that magnetic energy got converted into electrical energy, isn't it? Now this electrical energy is in such a direction that it opposes the magnet. It opposes the magnet, then this magnet got repelled. It means that magnet moves this side, it gets repelled because it is opposing. Then again it moves this side, mechanical energy, so electrical energy got converted into mechanical energy. In this way the same energy is being converted from one form to another. Conservation of energy is neither created nor destroyed, just got transferred from one form to another. In this way it is in accordance with the law of conservation of energy. This is all about the Lenz law, okay. Now basically Lenz law का अगर expression लिखना पड़े, it is same. Faraday law of electromagnetic induction, we wrote that E equal to d phi by dt, isn't it? Now यहाँ पे just we will use minus d phi by dt, okay. Minus because it is of opposing nature, it is just showing the direction, okay. It is of opposing nature. Now one thing in the last class we did, it means in the last video we did induced EMF in a rectangular coil moved in the presence of magnetic field, okay. Here we used the magnetic, it means we used the electromagnetic inductions law, Faraday's law, E equal to d phi by dt. Last में जाके we ignored the minus. अब एक चीज़ हो सकता है यहाँ पे, we can directly use Lenz law, okay. We can use from Lenz law E equal to minus d phi by dt, and minus यहाँ पे रहेगा सब जगह, minus and last here minus will be plus, and then we do not have to ignore the minus. There will be a logical explanation to this. So in place of electromagnetic induction law we can also use Lenz law. It is your wish, you can use anything, correct दोनों ही रहेगा, okay. Now moving on to our topic, self induction, okay. Now basically for self induction we need to draw figures. This is a battery, okay. This is a battery and here is a K means key or a switch, okay. Here it is a rheostat, and here it is a solenoid or coil, anything, okay. This is the coil, this is a rheostat, this is the battery which is the source, okay, source, and this is a switch. Easy, simple. Battery, rheostat, source. This is used to change the current. Now see, whenever this whenever this K, which is the key, okay, this is closed, it means that the switch is off, then the circuit becomes complete, then current flows through the circuit, isn't it? Now see, current begins to flow through the coil. Now whenever the current in this coil, it is increased with the help of rheostat. Rheostat का काम क्या है? Current increase या decrease करना. Whenever this current flowing through this coil, it is increased with the help of rheostat, then the magnetic flux of the coil will also increase, isn't it? See, more will be the current produces electric field, produces magnetic field, Faraday said. Okay, so more will be the current, more will be the magnetic flux. मैग्नेटिक फ्लक्स मतलब जितना करंट इससे जाएगा उतना ही मैग्नेटिक फ्लक्स में चेंजेस होगा. जितना मैग्नेटिक फ्लक्स में चेंज होगा उतना इंड्यूस्ड ईएमएफ विल बी प्रोड्यूस्ड. सो सी, व्हेनेवर दिस की इज क्लोज्ड, okay, then the current begins to flow through this coil. As the current is flowing through this coil, and when it is increased with the help of rheostat, then the flux linked with the coil also increases, and hence the EMF induced will also increase. Now this EMF is of opposing nature according to Lenz law. This EMF is of opposing nature. Now see, similarly, when the current flowing through the coil is decreased with the help of rheostat, then the current flowing through this will decrease, magnetic flux will also decrease, and the induced EMF will also decrease. So basically, what is self induction? It is the phenomenon in which opposing EMF is induced whenever the current flowing through the coil changes. So this will be the definition of the induction. This is the phenomenon in which the opposing EMF is induced in the coil. Opposing EMF is induced in the coil whenever the current in the coil is changed with the help of rheostat. It is increased, decreased, the current is changed. Okay, when it is increased, the induced EMF will increase. When there is decrease of current, induced EMF is decreased. So this is called self induction. Okay, so basically we can see the definition to the phenomenon in which the opposing EMF is induced in the coil when the current flowing through the coil changes. It is known as self induction. It is also known as back EMF. Back EMF, it is known as back EMF because it is of opposing nature. मतलब ये opposing nature का होता है ना, so it is called back EMF. Okay, that's not a important terms. Now we'll go for coefficient of self induction. Okay, or this is self induction of coefficient of self induction. It is the measure through which we calculate the value of self induction. So in this, if it is asked to calculate the coefficient of self induction, it is very easy. We know that, see, we said that this current is directly proportional to flux, isn't it? Or we can write opposingly. See, the flux linked with the coil, it is directly proportional to the current. More will be the current, more will be the flux. So a proportionality sign will come L. So this L is called the coefficient of self induction or self inductance. This L, okay, when the value of I will be 1 ampere, then this phi will be equal to L. Phi will be equal to L. So L, now from here we can see the definition of L. So coefficient of self induction, L, or self inductance, it is defined as the flux associated with the coil when 1 ampere current flows through it. Very easy. It is the flux associated with the coil whenever 1 ampere current flows through it. For another definition, we can use Lenz law. See, for another definition, E equal to minus d phi by dt. So E equal to, phi means Li. I said phi is directly proportional to I, so phi will be Li. Phi will be minus d Li by dt. L is constant, it will come outside. L minus di by dt, so minus will be here. Okay, di by dt. Now whenever di by dt will be equal to 1, this is ampere, this is second, 1 ampere per second, so E will be equal to minus L. Okay, so L will be equal to minus E. So again we have another definition. The coefficient of self induction or inductance, it is defined as the opposing, minus sign, opposing EMF induced whenever there occurs 1 ampere rate of change of current. Di by dt means rate of change of current, isn't it? So it is defined as the opposing EMF induced in the coil when there occurs unit rate of change of current. Di by dt is 1 ampere per second, then it will be equal. Okay, so this is in this coefficient of self induction. When it is said, we'll just calculate the we'll just find out the two definitions of this. Okay, this is not a derivation, this is just an understanding. Just usually this is not asked. Now the thing which is asked is coefficient of self induction in a solenoid carrying current and in a plain circular coil carrying current. Mutual inductance maybe ये बस ये one will calculate the coefficient of mutual induction, and then we'll calculate in solenoid, we'll calculate in plain circular coil. बस इतना ही है. So see, first of all, coefficient of self induction in a solenoid carrying current. For this, if you want to make a figure, you can make the same figure. Okay, as a figure is not necessary, still you can make the same figure, that this is K key, okay, solenoid, and then rheostat, okay, rheostat, and then the same figure. Now see, let's consider solenoid having small n is for number of turns, capital N is of number of coils. Okay, so see here solenoid में turns होता है, these are turns. Plain circular coil में coils होता है, so it is capital N, but here it is small n. Okay, so let us consider solenoid having n number of turns per unit length, number of turns per unit length. Okay, this solenoid का length is L, so let the length of the solenoid be L, and the current I is flowing through it. Okay, so we know that flux associated with this solenoid, it is B equal to mu naught Ni. We'll use the infinite wala expression because we do not know the exact length of the solenoid. It can be infinitely long as well. We are saying it is L, but it can be infinitely long as well, hai na? So as per Biot-Savart's law, B equal to mu naught Ni of solenoid, infinitely long solenoid. Okay, B equal to mu naught Ni, so it will be mu naught Ni by L. Now see how N became N by L. ये एक confusion हो सकता है. Only one thing to remember in this, N becomes N by L. So we are calculating in terms of capital N. Okay, this N is the number of coils. See, I said that N is the number of turns per unit length. It means that this is a solenoid, and in 1 unit length, 1 cm, or I have said this earlier as well, 1 cm or 1 meter, kitna bhi unit length mein there are n number of coils. Then in total solenoid, it means L is the length, then in total solenoid how many number of coils will be there? N into L. Okay, the solenoid can form a coil as well, huh? So how many number of coils, how many number of turns, anything, capital N will be equal to N into L. So capital N is N into L, so small n is N by L, so it become N by L. Now see, B is mu naught Ni by N by L. Now flux associated with the solenoid, we know flux is B into A, isn't it? So अब यहाँ पे n number of circular coils, so NBA phi equal to NBA. B का value now we'll put N mu naught Ni by L into A. Okay, this will be our expression. N into N become N square, isn't it? So equation to anything. Now we know phi equal to Li, so just put the value, this phi and this phi, equate the equations, you will get the value of L. Again I'll repeat, see इसमें कुछ नहीं करना है, just only the flux associated, okay, converted in terms of capital N. Then when the flux associated is phi equal to NBA, but according to this coefficient of self induction, phi is also equal to Li. Just equate these both, simple, we get the value of L. Coefficient of self induction came. Plain circular coil में भी वही है. Let us consider plain circular coil means this, isn't it? Plain circular coil. Let us consider coil which is n number of coils, capital N number of coils, through which current I is flowing. Simply magnetic flux associated with this will be mu naught Ni by 2R, center of the circular coil, mu naught Ni by, again the same thing, the flux we know it is NBA, n number of circular coils, so it will be N into mu naught Ni by 2R into A. This is equation 2, but we know phi equal to Li, so just equate those equations, get the value of L. Simple, very easy. These both topics usually पूछता नहीं है, ये बहुत easy है क्योंकि, फिर भी just revise it. Okay, now the last topic of this self induction. Okay, इसके बाद mutual induction and then the topic finishes. The last topic, energy stored in solenoid carrying current. Now this energy stored in solenoid carrying current is not used in mutual induction, it is only used in self induction. So energy stored in solenoid carrying current, so again make the same figure. Solenoid carrying current, key is there, solenoid is there, rheostat is there, connection. Okay, now see its length is L. Let us consider solenoid having n number of turns per unit length whose length is L. Current I is flowing, and here one thing, उसमें area का काम नहीं था, यहाँ area का काम आ जाता है. Okay, no वैसे we can write their area, we missed one thing, but we can write one thing, that it has area A. Okay, similarly here also it has area A. Okay, so now for energy stored in solenoid carrying current, just we need to remember some steps. See, कंफ्यूज नहीं होना इसमें, जस्ट फ्लक्स डेंसिटी then phi and phi, equate those two, and in this energy stored, first of all we'll do from Lenz law. We'll start from Lenz law, step by step. We just need to remember in this, बाकी सब तो calculation है, easy है. Minus d phi by dt. Phi means Li, we know phi means Li. For self induction case, only in self induction phi is Li, okay. So dt, so E will be equal to minus L di by dt. This same thing we did in that definition one also. So the definition one also we did the same thing, E equal to minus di by dt. Okay, this became equation 1. Now as the opposing EMF is induced in the coil, it opposes the flow of current, है ना. मतलब see, this EMF is of opposing nature, I said. So it opposes the flow of current, opposes the source, okay, Lenz law. It opposes the source. So the work to be done, for the current to flow in this coil, the work should be done against this opposing EMF, isn't it? See, this EMF is induced which is opposing the current. So the work to be done, so the current to be flown in this circuit, the work should be done against this opposing EMF, है ना. So now see one thing. If you see your notebook, you will find a very long and very confusing one thing, okay. यहाँ पे बहुत सारे assumptions है, बहुत सारी confusion भी होगा, यहाँ पे बहुत सारे formulas याद करने पड़ेंगे इस चीज़ में. So I have calculated a very simple expression, or you can say very simple derivation for this. So see, don't do this, okay. Till here do the same and then see. We know power equal to VI, okay. Remember power equal to VI. In case of this we are writing E, okay. V के जगह तो E है, induced EMF है ना. So P equal to EI. Now see, E we have minus L di by dt. Put the value minus L di by dt into I, okay. Now see, so the work to be done, now let dw be the small work done in small time interval dt. Now see, we are calculating that the current should be flown against this induced EMF, so it has to, so the work is to be done against this induced EMF. So let dw be the small work done in small time interval dt. So we know that dw will be equal to power into dt, because see, w equal to पावर इक्वल टू वर्क बाय टाइम, ओके. वी नो पावर सी, पावर का दो फार्मूला हमेशा याद रखना, बहुत काम आएगा ये लाइफ में भी. पी इक्वल टू ई आई, पी इक्वल टू डब्ल्यू बाई टी, ओके. सो पी इक्वल टू ई आई वी यूज्ड, इट केम दिस वन. नाउ अगेन पी इक्वल टू डब्ल्यू बाई टी, सो पी इक्वल टू डी डब्ल्यू बाई डी टी वी कैन राइट, है ना. सो डी डब्ल्यू विल बी इक्वल टू पी डी टी. नाउ पुट द वैल्यू ऑफ पावर देयर. नाउ डी डब्ल्यू बाई, सो इट इज माइनस एल डी आई बाई डी टी, दिस वैल्यू minus L di by dt, I into dt. So dt cancel, left is minus L di by minus L di into I. We can write minus L I di. This is the expression left, okay. You do the calculation, it will be very simple. dw we have minus L I di. Now we'll just integrate it to get the total value of work done, okay. So total value of work done w, एक चीज़ है यहाँ पे, you can use the integration, you cannot use. Want to use the integration, it will be 0 to I naught. Why 0 to I naught? I naught is the maximum value of current, okay. I naught is the maximum value of current. So see, we have dw, so it will be 0 to I naught Li di. So just integration, L is constant, it will come outside. L is constant, I is not constant, okay. Current तो कुछ भी हो सकता है, current तो कितना भी पास कर सकते हैं. And one thing, rheostat is there. Rheostat is changing the current. Remember, rheostat is changing the current. So current is not constant. L I d. So according to integration, it will be I square by 2, 0 to I naught, okay. So one thing I'll teach you integration one formula. See, integration का एक formula होता है. If your expression is somewhat like this, okay, nx dx, then its answer will be n x plus 1 by x plus 1. Now see, suppose ये है 2 to the power 2 dx, okay. Suppose it is 2 to the power 2 dx, okay. So 2 नहीं, a to the power square dx, okay. So it will be like a 2 plus 1 by 2 plus 1. Suppose it is a to the power 3, okay. Integration a to the power 3 dA, then it will be a 3 plus 1 by 3 plus 1. Similarly here see I di, so I का value तो यहाँ पे 1 है, so 1 plus 1 is 2 by 1 plus 1 is 2. Okay, like this it came, I square by 2, integration है. Now see, just put the values. First of all, upper value I naught square by 2 minus it will be 0 का value डालने पे 0, so it will be 1 by 2 L I naught square. This is the value of work done. Okay, this is the basic value of work done in a solenoid carrying current. So it was very simple. Okay, just Lenz law say E equal to minus L di by dt, then use the power EI, power equal to EI. Okay, power came minus L di by dt I, and then we also know power equal to EI. So we'll just put the values and calculation, just integration. Okay, this is all about the self induction. In the next video we'll be learning about the mutual induction, and don't forget to subscribe the channel. Thank you. And yes, one thing remaining. See, I told you that power one thing, the alternative way to do this, so it is not done in notebook, so you can screenshot this. Okay, screenshot this first, and then I'm telling you. Okay, so hopefully you have taken this screenshot. So I just want to say that in this energy stored in a solenoid carrying current, it is one of the most important topics first of all. Now see, मतलब यहाँ तक तो same है, till here you can do the same. Okay, till this, but this much I have done in this alternative way. This is much more easier to understand as well. Okay, so in place of this you will do this, and then the integration part is again the same thing. Okay, integration part is again the same, so only this part is of middle part, from this flow of current is to this integration part. In place of this you will do this. Okay, thank you.